Welcome back, Algebra 2ers. We'll be taking a look at 4.4, still working with quadratics, still working with parabolas, but now we're going to be looking at them in a different context where we're being asked to look at factoring. And this is a few options with how we'll see it. We'll see perfect square trinomials, so terms that can be factored to just one binomial that's squared, similar to x plus 5 being squared in parentheses. We'll also see the idea of a greatest common factor that's factored out, and also the difference of two squares. With this first piece of paper, this just gives you the idea of kind of working towards factoring. Sometimes I don't know. I feel really indifferent about these introductions that they do, but in here, in a game, you see two cards shown, you get the two other cards with numbers. You win if the product of the two numbers equals the number on one card shown and the sum of your two numbers equals the number on the other card shown. What should your two cards be for you to win the game? Is there more than one answer? Well, if we talk about this, can the two numbers on the cards be negative? Yeah, they could. The only problem states that the cards have numbers. It doesn't really specify positive or negative. With factoring, with rewriting trinomials, this is definitely something to keep in mind because as we see here, asking us for the product of 5, we could have 1 and 5. We could also have -1 and -5. So if we tie this back into here, there's only one option that's actually going to have the sum of 6 that they're looking for, even though we have two options for the product. Does this mean that 1 and 5 are the only possible numbers that could be on your two cards? No. We could have a variety. We could have had a product of 6 and a sum of 5. For example, 2 and 3. So there are tons of options we could have here. And factoring is really crucial because it's really a way for us to rewrite expressions. In pre-calc, you'll see factoring. Further on in this course, you'll be asked to see factoring. But what's nice is that we can use the distributive property or the FOIL method, what we'll eventually see. I think we already have seen this box method in here. If I taught you last year, box method should sound familiar. And we can always check our work. So this is a really great way for us to check our work. But we'll keep this moving. They talk about the distributive method, and this is a way for you to check your work. If you want to pause this and look at it, go for it. But if you have your outline, you already have this together. They build the idea of factoring, talking about what this is, saying that the factors of an expression are similar to the factors of a number. Okay, yeah, I can get behind that. Because if we looked at 10, factors of 10 are 5 and 2. We also have 1 and 10. We know that these are factors because if we took 2 times 5, that would get us 10. We know 1 times 10 would get us 10. And so we'll take a look at a few examples here. We'll definitely practice this in class because this section is really important and we'll definitely come back again and again. So if I've taught you previously, diamond method is going to be coming back here, but if I have not taught you previously, then stick with me. So we're being asked to find the expression in factored form of x squared plus 7x plus 6. And so the way that I personally factor and think out my thoughts, similar to the introduction where we had to find the product of one number and the sum of the other, is using diamond method. And we'll see how this works. I think this is a really great way for you to organize your thoughts before you write your answer. So how this works. If we draw an X, not quite a diamond, but work with me on this. Down here, we're going to be writing our C coefficient. So our C coefficient, if you want to call that the product, that's also something to consider because I may go back and forth referring to the product and also referring to C. And that's the number we're trying to get. And we might also want to include in green our sum. Hopefully this shows up. Oh, it did. How about that? Which is our B coefficient, where eventually on the left and the right side, we're going to have factors. So this will be factor 1, factor 2. And the reason that I set this all up is so that before I make a final move and make a final answer, I'm finalizing all of my thoughts before I go any further. Once you go forward, and let's say it's on Math Excel and you put in your answer, it's done. You can't really go back. But with this, if you strategically think out your factors and make sure everything checks out, that's good. So let's try it with this one. So our product is positive 6. Make sure to include your signs. Our sum that we're aiming for is positive 7. And so the questions that we're asking here are, what factors of positive 6 add up to 7? This is the question that I'm asking myself whenever I work with a factoring problem. What factors of this number are going to add up to this number? And as we saw in the intro, some of these can be negative. One of them could be negative. They both might have to be negative in some circumstances, but I'll give you a moment to think this out. 6 has factors of 2 and 3, but also 6 and 1. 6 and 1 is the one that's going to work. I read in that these are positive just for the first few examples. So using these factors, 6 and 1, we know that this is dealing when the A term is positive 1 or negative 1. When it's negative 1, we might see that down the line. But we can easily just place our factors in binomials. So we'll put plus 6, plus 1, do x here, and we're done. So think, how could we check our work on this? Well, if we use box method, I'll show that over here. We have x plus 6, x plus 1. We dash this out, x squared, 6x, positive x, and 6. If we highlight the terms that we can combine, these for the most part are going to be on the diagonal. I can't think of another circumstance where they wouldn't be. But if we take this further, we have x squared plus 7x plus 6. Because if we combine 6x and x, that gets us 7x. So this is good. And this was the way we could check. I'll give you a moment to try the next one. So with factors of 40, sum of 14, 4 and 10 make the most sense here. X plus 10, x plus 4. Final answer is seen here. If you're not convinced, FOIL this out, use box method, do whatever you have to do to make sure it sounds good to you. We then also introduced the idea, and we've kind of seen this previously. We saw this in the Chapter 1 review, dealing with greatest common factor. I think the problem that was there was xt minus xu equals 3t, something like that, where eventually, hopefully we can see that there are common factors with these two terms. And this is something you should always be on the lookout for, because as you see here, if you try to use diamond method, you're looking for factors of 0, and that's not going to work. But all we can really do is find common factors. So what do these two terms have in common? Does 4 share a common factor with 28? Do the variables have anything in common that we can factor out? Hopefully you're saying that we can take 4x out. And if we take 4x out, what's going to be left over in our binomial? Well, we're thinking, what times 4x gets us 4x squared? This would have to be x. And then also, what times 4x gets us negative 28x? This would have to be negative 7. And we can't do anything else from there. But we can always check our work by distributing, so keep that in mind. I'll give you a moment for the next one. So the only thing in common here is 7. Nothing with n, because notice n squared is only seen here. 21 doesn't have an n term. closest factored form we can end up with is 7 parentheses n squared minus 3. And again, if you're stuck on any of this, please let me know. But a lot of this you should have seen in Algebra 1. If on the off chance we end up factoring when our a coefficient is not 1, there are tons of ways you could do this. I mean, the one way I'm thinking of, just because I've seen how these problems work, I know that 2 is prime. So this also makes me believe that the first two terms in the binomial have to be 2x and x. So that's something you could sketch out if you really want to. But for this one, I'll use diamond method again. And what's different about this, since a is no longer equal to 1, this is really crucial. So please take note of this. Our a coefficient's no longer 1, so diamond method is modified here, where now we take the product of a and c. So we take the product of our a coefficient, 2, and our c coefficient, or constant in this case, negative 12. And we still keep our b term there. Factors are going to go on the left side and the right side. So for this one, I'll redraw this. If I take the product of 2 and negative 12, this is negative 24. 5 is our middle term. I know that my product is negative, so that means one of these terms has to be negative. That's for certain. I'm thinking factors of 24. There's 1 and 24. There's 2 and 12. There's also 3 and 8. The one that's going to work the best here is going to be positive 8 with negative 3. And so the way that we rewrite this, instead of just saying, all right, it's x plus 8, x minus 3, we're done, we have to rewrite the middle term. So what was originally 2x squared plus 5x minus 12, I'm going to rewrite to 2x squared plus 8x minus 3x minus 12. So notice that I rewrote my b term here, which is totally fair game. If you're not convinced, think this out. 8x minus 3x definitely gets us 5x. And from here, this is going to be factoring by grouping. So you might have seen that in Algebra 1, but if we factor by grouping, it's as if we're taking the greatest common factor from these first two terms, which in this case would be 2x, leaving us with x plus 4. If you've factored the first two terms correctly with their greatest common factor, ideally the binomial over here has to be the same. And this is really, really crucial, so I'll even highlight this. But we factored the first two terms for greatest common factor. We did that correctly. So we know that when we factor the second pair of two terms, that binomial x plus 4 has to be seen, or else we need to modify it and make it there. In this case, what we can factor out from negative 3x and negative 12 is going to be negative 3. So if we take negative 3 out, from here we have x plus 4 as one of our factors, and also 2x minus 3. So this does use the two greatest common factors that we found. And eventually, when you're really slick at factoring, you don't even need to do this method. Again, as I mentioned at the beginning, I knew that 2 was prime. So just based off of this fact alone, I knew that I was going to have 2x multiplying with x in that very first term. And then you can kind of guess and check the other numbers. I'll give you a moment for the next one. So pause the video, give that one a shot, and I'll talk about it. Your product's definitely 12, sum's definitely 7. This would only occur if you had positive 3 and positive 4. If I rewrite this middle term, 4x squared plus 4x plus 3x plus 3, factoring out 4x, final answer, 4x plus 3, parentheses, x plus 1. And again, if you're not convinced, check your work. We then see perfect square trinomials. I drew out an example of this at the beginning, but this is a trinomial that, when factored, is just some binomial being squared. So if we take a look at this, we'll see a lot of perfect squares as far as the end factor goes. So an option you have here is to use diamond method. That's cool. I'll show both methods actually. So if I was using diamond method, I know my sum is -12, my product's 36. This is a negative sum, but a positive product. So these terms both have to be negative. -6 and -6 work. This would have to be x minus 6, x minus 6. But the idea that they're going with here is rewriting to the binomial being squared. So you could just rewrite this to x minus 6, parentheses, being squared. But when you're really slick, you know that you have a perfect square here. You kind of have a perfect square at the beginning also. Square root of 1 is 1. Square root of 36 is 6 and 6. You know that your middle term's negative. So if you use this idea, coefficient for x has to be 1. You're subtracting 6. And then let's cap that with parentheses. And that's only if you're really slick. Give the next one a shot. Square root of 64 is 8 and 8. Square root of 1 is 1. The middle term's negative, so this has to be 8x minus 1 being squared. If you really want to go for diamond method, product is 64, sum's -16. This one, again, you would have to work with the middle term, so noticing patterns like 64 is a perfect square, 1's a perfect square or perfect number. -8 and -8 work here. If you rewrite the middle term, it looks like this. If you know how to do all of this, that's awesome. Again, the reason I'm really highlighting on every little problem in this section is because I think this section's really important and definitely does build. And as you see here, we ended up with that same outcome. Both are fair game ways. If you're really on your stuff, you'll know how to do the first one just fine. We then see the idea of the difference of two squares, where similar to perfect squares, we have terms that are perfect and can definitely be taken square roots. But the way that it's factored uses those factors where one has a positive second term, one has a negative second term. And you'll know that this is a difference of two squares because there's no middle variable of, let's say, x to the first power or b to the first power or c to the first power, what have you. There's no middle variable. There's only x squared and there's a constant. So I know this is a difference of squares because there's no x term on its own. Square root of 81 is 9 and 9. Square root of 100 is 10 and 10. We have 9x minus 10 multiplying with 9x plus 10. Final answer. I'll even check my work on this if you're not convinced. But you should believe me. A lot of this should be something you've seen in Algebra 1. You might need a refresher, which is just fine. As we see here, box method is really a great way for us to check our work, and if you're really quick with it, it shouldn't take too much time. But the main idea is that if your middle term cancels when you check box method, chances are you're in good shape. So this was a way you can check. Because if we have 90x, we take away 90x, those cancel, just leaving us 81x squared minus 100, which was the original polynomial we had. Sorry for the long video. Pause if you have any questions. Email me if you have any questions. Come to class with any questions.